Black holes. They're scary, weird, and mysterious. We don't even know all the things about them. They are formed when a star burns all of its fuel and the balance between fusion and gravity is broken. Gravity overpowers the force that fusion exerts on the star, and it collapses on itself. A black hole has just been created. Can you see it? Well, no, because it's way smaller than the star it used to be. Let's zoom in. Can you see it now? No, a black hole emits no light, so you can't see it at all. Okay then, let's just put a star near it, so that we can see the light that reflects off of it. Nope, still can't see it. A black hole's gravitational pull is so strong that light which gets near it is sucked in it and is never seen again. In high school, you might have learned that gravity only attracts objects with mass. That's a common misconception. Gravity attracts anything that has energy, not mass. And light has energy. Okay, if we can't see black holes, how do we even know they exist? Well, light that comes from behind the black hole can get distorted. If that happens, whatever emitted the light from behind it can look very weird, almost unnatural. There's something even weirder than black holes though. Something that hasn't even been discovered yet, only theorized to exist. You might have heard of them or seen them in some movies. Wormholes. These things are practically black holes, but there's a fundamental difference. Wormholes can transport you in a different part of the universe, possibly faster than light, or even in another universe. That's crazy! Now, for wormholes to actually be possible, the universe needs to be curved. What the hell does that even mean? Well, if you pay attention to this illustration, you can see that the universe is curved. If the universe is flat, then the fastest way from A to B is always the straight line between A and B. Hence, wormholes aren't possible. Sadly, there's reason to believe that our universe is in fact flat. In this case, flat doesn't mean flat like a sheet of paper. It's just a way of saying that the universe's geometry is the kind that allows parallel lines to never cross, or the sum of all the angles in a triangle to be 180 degrees, or the edges of a square to always be right. As you can see, if the universe were open, the sum of all the angles in a triangle would always be less than 180 degrees. And if the universe were closed, the sum would always be more than 180 degrees. Don't worry though, it's possible that the universe is in fact curved, but it's so big that it's unnoticeable. Just like you can't see the curvature of the Earth while standing on it. To actually test this, we would probably need to have a triangle that's millions, maybe even billions of light years across to actually have any noticeable effects. Basically, the conclusion is that we have no idea. Okay, wormholes are cool, but the same universe traveling thing is kind of boring. Happily, wormholes could theoretically be used to travel to other universes as well. A multiverse is like a universe for universes, and if it exists, then our universe is just one out of a lot of other ones. If that's the case, then all the universes that exist could be stacked one over the other. A wormhole could just make the connection between our universe and the parallel universe. This is an artist's representation of what that would actually look like. On the right, you can see the universe that you are from, and to the left is the parallel universe that you are currently going into. Wormholes are weird. They're not even confirmed to exist, but we have a lot of theories on them already. Technological advancement only accelerated in the past few years. So who knows what the future holds for us. Maybe we'll even be able to make use of them and travel along huge distances, although for now we can only dream. Thanks for watching. If you enjoyed the video, give it a like. And if you'd like me to talk about anything else next video, please leave a comment with a suggestion. Goodbye.